Hey everyone, a lot of you want to learn AI, but you're not sure where to begin. What's the complete syllabus? What are the resources you need? Who to follow, etc. From freshers to middle level professionals to even senior managers, a lot of them have this question. Everybody's got sort of a fragmented idea about it, but not a complete structure. So let's bring that clarity to your mind. In this video, I'm going to explain the entire AI learning roadmap in simple terms. First, I'll give you a big picture of the list of all the topics we must cover in this journey. Then, I'll explain what each topic means on a high level. By the end of this video, you will know the exact path to learn AI from zero to finish. Everyone, welcome to Dear Mind. My goal here is to help you understand complex topics in simple terms and bring clarity to your mind. Let's get started. By the way, this is a chalk and talk method to help you take notes as you prepare. Notes will be very important later on. So it also helps you focus and get the satisfaction of learning. So come on, pause now and get your notebooks out. If you're absolutely new to I want to say AI is easy and interesting once you learn it the right way. So don't get overwhelmed by complex topics or terminologies when it comes your way. It's all perfectly doable. I will ensure you learn it easily. And as a quick disclaimer, I'd like to say that everything discussed here reflects my own research and opinions only, and not those of any past or present employer. Well, let's get started. So, as I said, the big picture, right? What is the complete AI syllabus in under a minute? If you ask me this, I will say first you will be starting with a coding language. Okay. After that, you will be learning what is called as the classic machine learning. So once you're done with that, then we will be moving to deep learning. So after deep learning is completed, you will learn natural language processing and computer vision. So these two are like two different paths. Generally, people tend to take the NLP path or the computer vision path. So NLP is about word processing and CV is more about image and video processing. Okay, these are all predominantly what is happening within these two technologies. So this is what you will learn, and after that, you will get into large language models. So once you learn about these, you will get into this generative AI topic. So once generative AI is covered, the last and final topic will be agents as of date. This is the latest topic that has come up in AI. So this is your complete picture of your AI learning roadmap. All right. So let's say people are of different experiences, right? So you may be a fresher or a mid-level professional. So where do you start? Obviously, as a developer, you will be starting from here. This will be your start line, and you will go on up to here. This will be your finish line. So this will give you a wholesome learning and understanding. Let's say you are a senior manager. So by senior manager, I mean you have somewhere about 17, 18 years or above experience. Okay, more experience than that. In that case, you can just start from here as well. Okay, because I believe you're not going to do any sort of development work, you're going to delegate work. So for you to understand all the applications and how things are working in the background, right? I would say, yeah, as for a quick catch up, this is enough for senior managers, for you to just start with understanding what is LLMs, generative AI agents. Of course, you will need to understand a little more of deep learning, NLP, everything, now like how transformers are um, working and all that. But for senior manager, my perception is that it would suffice if you start from here. All right, now let's get into the details. Step 1, coding language. So the most common coding languages that are used are Python and R. in data science. Okay, so if you're absolute fresher, you're going to just start learning a coding language, I'd say go with Python because it's much more versatile than R. R is also a very easy language. So if you already know Python, if you want to explore, I'd recommend you can go ahead and learn R as well. But if you want only one language, I would recommend Python. Go with that. So next thing is classic machine learning. Classic machine learning, it was actually called as machine learning only. Now it has become classic machine learning. And it is also called as traditional AI these days. Okay, so here in machine learning, what you will learn? You will learn to create models. What models? Machine learning models. Okay, so what are these capable of, right? What are machine learning models capable of? Two major capabilities are there. One is prediction, other is classification. So let's understand quickly what is prediction and classification. Okay, so prediction, let's say you have a cloth store. Okay, you have been selling jeans. Last month you have sold 10 jeans. So what are you going to sell next month? What is your sales forecast? That has to be predicted, right? Which will help you in your business. That sort of prediction ML model will be able to do for you. Okay, so that is prediction. Next is classification. Let's take a bank data set, finance data set. Okay, a bank wants to classify its customer and understand to which customers it can approve a loan and to which customers it should not. So it's trying to classify its customers, right, based on the data it has. So that is a classification use case where you can employ ML models to tell you that. All right. So this is a prediction and classification capabilities of machine learning models. Now, let's dig a little more and understand how machine learns. That is other way of putting like what is machine learning, right? Okay. So this happens in two steps basically. One is model training. Model training is your first step. Second step will be your model output. Okay. Now let's suppose you have a data set. Okay. Date, name, gender, age, holiday, products. In these places, I'd recommend you can go in 2x speed. Okay, play the video in 2x speed when I'm drawing a table and all right. So the first one is date. Let's say it is 25 December. Okay, name is Deeps, gender is male, age is 20. Is it holiday December 25? Yes, it's a Christmas holiday, and he has bought a t-shirt. Let's say another example, 26 December, customer name is Ani, male, 22, not a holiday, and he's bought a jeans. Let's take one more record here, 27 December, Lata, female, 23 years old, not a holiday, and she's bought a t-shirt. Okay, so let's say this is a Excel data that we are having. All right, so when you say a machine learning, how it learns is, so we have a historical data over here. Okay, this is the Excel that we're talking here, this one. Now we will feed this data to a model. When you say model, what it means is it's basically an algorithm. Okay, this we'll learn and understand later, but just for now understand that we are passing the Excel to a model. So once we have done that, what happens is this model tries to figure out it figures out a pattern from the data set that was given to it and comes up with a function. When you say function, think of it like a formula. It's coming up with a formula. Okay, so what happens is it is looking at the data set, it's understanding, okay, customer name Deeps, he's a male of 20 years of age. On a holiday he is buying a t-shirt. Okay, there is another customer who's a male and of this age. On a non-holiday he's bought a jeans. Okay, this is another customer, Lata. She is female and of this particular age, and on a non-holiday she is purchased this product. So like that, it's trying to learn from the data and understand the pattern that is underlying in the data. Okay, that's what the algorithm is capable of doing. Now what happens? So once it has been trained on this data, here you will get a trained model. Trained model, right? Now, this is your step one, this one. So, as a step two, we should look at the model output, right? So, the step two here will be you will make use of the model that you trained, right? The trained model you will have, and next is you will pass new data to it. New data means, let's go back here quickly. Let's say you are having another data next month, okay? Let's say 25 Jan. You're having another customer called Sudha. Okay, and you can have different parameters. She can be a female, she can be a 25-year-old, it is a non-holiday, whether she will buy or not, right? What sort of sales is going to happen, that prediction we can have, because the model has trained, it has learned, and now it will be able to say whether this person will be able to buy or not, right? So that kind of learning it would have had. Now the trained model will take the new data and give a output. Okay, as we know, there are two capabilities, right? It can make prediction or classification depending on the use case. So this is how machine works. Machine learns and provides an output. Okay, now we have talked about algorithm here, right? Model here. So that means what are the major algorithms that we should know? Okay, major algorithms are linear regression, logistic regression, decision tree, random forest, support vector machine, also called as SVM, XGBoost, etc. These are some of the major algorithms that we are using in machine learning to basically predict or classify stuff. Okay, so when you say you have studied all these algorithms, that means you have covered classic machine learning syllabus. Okay, so this is going to be your actual syllabus in traditional AI. Next, now that you have understood what is machine learning and what you're going to be studying in that, the next one we'll be moving on is to deep learning. Okay, in deep learning, what happens is complexity increases. What complexity increases? Data complexity increases, model complexity increases. Okay, so when you say data complexity, what is getting complex here? It can be quantity, of data, it can be the type of data, right? So what do you mean by type of data here? Type means it can be a text data, it can be an image data, it can be a video data, can be sound, etc. So basically the complexity increases here. Okay, and we can say neural networks comes into picture, and it will have multiple layers. Again, this is something I'll explain in detail when we are talking about deep learning. Just try to understand on a high level at this point. So if you see in deep learning, there are two major sections. Okay, that is NLP, which is the natural language processing. Next is CV, which is computer vision. So natural language example is like it is all about word processing. Computer vision is predominantly about image or video processing. So for example, you know about a lot of real-time natural language processing applications. For example, if you take a chatbot, you're putting in your natural language and the bot is responding back, right? That is an NLP use case. Or you're typing in a text message or an email wherein you're getting recommendations of the next word in your sentence that you're typing, right? So that is a example of NLP application. Next, if you consider computer vision, we have heard about autonomous cars, right? Driverless cars. So what is happening there? A car is there, it's got a camera, it is capturing a lot of images, photos, right? And then it is processing those images and it is giving you a set of direction, or it is guiding the car itself to move in a particular path. So it is processing the image basically. So like this, there are many applications in these two domains. Okay, so I hope you understood what is NLP and CV on a very high level. And then in deep learning, what you will be learning, right? What you should be studying. So some example model architectures that you'll be studying are RNN, which is recurrent neural network. You'll be learning about transformers, which is a very, very, very important topic, very interesting topic as well. I'll tell you what this will do. Then you'll be learning about CNN, which is convolutional neural network. So if you see RNN, it is for sequential data processing. If you take transformers, it is for parallel data processing. CNN, if you take, it's predominantly for image or video processing. Okay, so these are the major architectures we'll be learning in deep learning. All right, next, once we are done with this, we'll be going on to a very interesting topic called large language models. You may not know how these large language models work at this moment, but I'm sure you've heard of large language models for sure. LLMs, right? Basically, they are huge models, okay, compared to other models that we create. And they are basically trained on billions of parameters. Let's say data, for example, okay, just data parameters, just think of it as data at this point. Okay, so they trained on billions of parameters. They need a lot of compute power, to run these models. Only huge companies can afford it. Okay, because it is very costly to get these models running. It takes time, power, performance, a lot of things are there. Next is we'll see some examples, right? We must understand some examples, but these are all something you are very familiar with. The GPT series, Gemini series, Claude family, Llama family, they all are large language models. Next is generative AI. I think this topic was in the news for a long time. So, why was there this hype? We already had traditional AI, but after generative AI came only, it was a lot of hype, right? We heard about it so much. So, what's the difference? We know traditional AI, classic machine learning, right? It can do predominantly prediction, it can do classification, it can do analysis, right? These things we were able to do. But when generative AI came up, we were suddenly able to generate content, right? We were able to create content. So what were we able to create? We were able to create text. We can say we are now able to create books, we are able to write blogs, we can have scripts, right? Lot of textual content, we are able to generate poems, it can be anything. Next, we are able to create videos, a lot of marketing videos now we are able to make on our own itself, right? You don't have to go to marketing professionals. Just you give a correct prompt and the video is getting generated these days. So that is one application. Then sound, music, we are able to have fresh music generated by Gen AI models. And in fact, recently I've heard in the news that some Gen AI developed musics are topping the charts also. People are really loving it, right? So music is being created. And then image, this is probably the biggest use case that everybody knows of, right? We're able to morph our photos, edit our photos, we're able to change background, we are able to add people, remove people, whatnot, right? So we are able to do image generation using Gen AI. So that is why sudden hype. So that is about generative AI. Next, the last and the most recent topic is agents. So what's special about agents? Agents have autonomous decision making power. They can make decisions on their own. Then they're able to connect to external tools. They can connect to databases, they can connect to browsers, they can actually equip themselves with a lot of external tools, and their capabilities are increasing much more because of that. Okay, so that's why it is very important in agents. Basically you can call them as advanced LLMs. That's what I feel they are. Okay, these agents are advanced LLMs. And mostly you'll see now going forward a lot of applications are going to be agentic solutions, right? In all the offices that we are working in, what applications we are creating in everywhere, there's going to be single agent, there's going to be multi-agent systems. So we're going to hear a lot about it, which we'll see in detail in the coming videos as well. So with this, I guess as promised, you're all set to begin your AI journey. And if this video brought clarity to your mind, hit that like button and subscribe for more. I'll see you in the next lesson. Thank you for learning with Dear Mind.